Hello, I'm Truman with Park Tool, and today we're going to be playing with some components. Some of these, some of these, and some of these. All right, Calvin.
Thanks, I've always wanted a wheel from you.
I know, okay.
Okay, not my
these
wheel.
are spokes. We've never built with these spokes before. These are Berd spokes, B-E-R-D. This material is from the company called Dyneema. They're then manufactured into spokes by the company Berd, and it is a ultra-high molecular weight polyethylene. They're extremely strong and they're extremely lightweight. They have a hoop on one end and they have a metal part of a spoke in the other end. We've never built with this hub flange style before. These are from a company called Onyx Racing Products. What they're most well known for is their instant engagement. So as you try to engage this, it almost like a negative engagement. It's really cool. But one of the very special things here is these hook flanges. And what that allows, we'll get to in a second, is this. You take one of the spokes and it hooks right on there. So this is a total new learning thing. So Calvin, well, we have Calvin here to ask some questions about this build and how it went, some of the hurdles that we had to kind of get over, and what were the differences.
And some of the fun I hope you had.
Exactly.
New stuff is always fun. So first, let's just start time. How was the speed? How did this build go compared to the good old J-band steel that we know and love? How was this new thing?
And this is the first time I'm doing this, so we're gonna be learning together. So I've built lots and lots of these. So that goes fairly quickly. The process is very straightforward. I know exactly the system, blindfolded. You could do it. We could do it.
Yep.
New process, which is interesting. What I found was there's more variables. There are a lot more variables as you're building. This build process starts a little bit different right out of the gate. So Onyx logo here, typically start about quarter down. We're going to be running our key spoke from here to here. But we're not going to be starting that way. We need to start actually with two spokes. So what you do is you take two spokes with two hoops and you put one through the other, and then you put them on the flange like so, which is interesting. But to your question about time, the first one took quite a bit of time. Let's say it took me 20 to 30 minutes, probably 30 towards that 30-minute mark to get that full thing laced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down here. Start using some tools. Look at that. That is cool. It's already holding itself in place. Pretty neat. We essentially have a wheel here.
That's
front wheel,
laced, not built.
Laced, not built, just laced up. And so that first one, then I noticed some problems that I had that I didn't necessarily know that I was gonna have. So then I took it apart.
That's two.
Then I built it back up, and then I took it apart again.
Three.
And I put it back together, and then I did a fourth one. A lot of it for learning and for changing things how I kind of wanted them to. But yeah, the variables that you don't have in a standard hub that you do with a hub like this and a spoke like this is interesting.
That is a fun part of this, because we're builders out there. I built, you built. We get locked in that paradigm. This is a new paradigm to this.
Yeah.
It's always fun to learn.
On these, there's a lot more choices, and that's where things were more interesting with these particular spokes.
And the paradigm begins even before you get these things and figuring the spoke length. The concept is the same, but it's geometry. We have a circle. We have a certain angle. We know the diameter. There's a rim. There's an effective rim diameter. But for a proprietary spoke, stick with that proprietary calculator. It's kind of fun here. What I like is the fabric nature of this. And that can be tricky when you take a system that we've always had and we're going to change just the material and expect things to be the same. They're not going to be the same.
Ooh. That made it quite a bit easier holding it like that. So holding it like this allows that hub to move and flex where I had it resting, and that was actually making it quite a bit harder. No.
We're used to steel, rigidity of steel. It's modulus. Modulus here, without tension, it's nothing. It behaves differently, pulls up differently. This doesn't even reach the rim like it would normally in the steel spoke, but once you've laced it tight, yes, there's good thread engagement.
Yeah, and once they're built, these are really solid. I really think these are going to be an amazing set of wheels. But the process, and now after building two wheels, one of them a few times, I think I could do it very quickly from here on out with the education just after the first one, really. That's
right.
Pretty fun.
That's right. So the amount of stretch, we had 3 days. It has to settle. It's a tight pair of blue jeans. You wear them all night and then they loosen up. You tighten them up the next day.
Yeah.
And it loosens up the nature.
We came back to our wheel. We left it at 100 kgf, which was 17 on the Park Tools TM1. So now on the tension side, which for this front wheel is the non-drive side or the disc side, and we're gonna find our valve hole here. We're gonna, backwards, man. We're gonna run this on there. Okay. We're running down 14, 13. So we have a fancy new paper here. Looking at, so 14, we were at 17 before. 14 on the Poly Light is about 77. So we're looking at 77. So roughly, 23 to 30 kgf loss overnight. So that's interesting. But let's crank it up, back up to 100, and let's see how much we lose tomorrow. Yesterday, we left these 17 on the Park Tool TM1, which is about 101 kgf. We're looking for 100. So now, today, we're down averaging, we're in the range of 15 to 16. So about 8 to 15 kgf drop on this third day. So quite a bit less, about half the drop from day 1 to day 2. So now we're gonna throw a little bit, probably a quarter turn. We're gonna see what happens there with a quarter of a turn to add tension to the entire wheel. Then we're gonna run through, check dish, do some truing, kind of perfect that wheel, and that'll be its continuous state for a long, hopefully a very long time.
Well, is it the actual fiber that's stretching, or is it that weave that's settling in?
I don't know the answer to this, But my thought is it is the weave settling in and the fibers
like
nestling to one another, because the fiber itself, the individual strands should not stretch a whole lot.
Right.
But the weave, as it all settles together, that's going to give you that stretching or that settling in. But to that, so the first day you obviously probably have the most settling. So we hit about 30 to 40 kgf through both wheels of settling. So went from 100 down to 60, 70. And third day, or so after that, the second settling period came back. We're talking a lot less, like 8 to 10 kgf. Much, much less settling on that second settling. So that's confidence inspiring, so it's not going to settle a whole bunch. And then it was the first one, that 30 to 40 kgf, I gave it a full turn. That was probably just a little bit much. I could have gone a little bit less than that full turn. To bring it up for that 8 to 10, it was about a quarter of a turn on the spoke. It was very, very quick tensioning on those second and third days. So.
Well, and these spokes are amazingly strong for this little piece of fabric, but it's still the rim that's settling or determining what we want for tension. The spoke can take it, so we're not really tightening for the spoke itself.
Yep.
It's for the rim. You don't want to over tighten for the rim for the same reasons. You can pull, damage, deform, crack right at the rim.
Yeah. Some other fun stuff that we learned here, tools.
Yeah, I was going to ask you about turning these. The J-bend naturally, the twist doesn't want to rotate, piece of steel doesn't want, there can be some slight rotation. That pinging and popping, you get, I don't think you're going to get the pinging and popping here so much.
The pinging and popping were happening here.
But you shouldn't let this thing twist round and round as you're truing. How do you prevent that?
So we prevented it with a tool from Berd. So this goes on to the spoke here on this little wrench, the little wrench flat here, to keep it in line.
Otherwise you're going to twist the fiber
a whole
round
bunch.
And round.
And then that's going to tend to weaken it.
Right.
So you don't want them twisted like that. You want them to be fairly straight. But another part of this, which you know from making the chart, so we made that chart, these are not perfectly round. They're almost bladed.
Ovalish, flattish, yeah.
And that's another challenge, another hurdle that I had to get through. And what that affects is your TM1 reading, because...
Or any tool. Any tension meter tool, it's going to affect it, because it's going to affect the distance, basically, where it
starts to make contact, and then your deflection reading from that point. So it was difficult. You could see a couple readings different from where they were, but it's really difficult to align them the way you need to once it's in a wheel.
And consistently.
So when it came to spoke tools, or nipple tools, so at the start of the video, we talked about all three of these, and I started off with the SW16. I introduced the flag to it so I could count how many turns. This was quick. It made for a fairly quick turning, fairly easy. I could choke up on it. I could spin it with my fingers. Pretty decent. I did end up moving to the SW15, the three-way, because you get a nice amount of leverage. And once you're at that, kind of towards that final tensioning, it's harder to turn the nipples. And then it's a little bit easier to kind of keep track of a quarter of a turn or a half of a turn and that kind of stuff with the SW15. I think it wouldn't have been the worst thing in the world to build the whole thing with the SW15. With a double square, with the secure lock, the double square secure lock Sapim nipple, I didn't find any reason to switch to the hoop style standard spoke.
And this is also interesting because, sure, I could get in here. I'm going to turn this. Whoops, I'm going to be rotating things round and round.
There's no room for this at that point.
That's right, but well, okay. keep going because I think we have something for our audience. Ta-da!
Yes.
The SW9. We thought about that. So some rims, you just have to do this. I'm holding here. Here, I'm coming from the side. So, yep. So there's a way to do that. So
Definitely. Pretty slick little tool.
And do not,
bone.
this is a good one. Do not, how about some pliers? Oh, I got some. These are good. This is actually one of my favorite pliers. I guarantee you I can hold that.
Yeah, don't do that.
Ouch.
Don't do that.
You're ripping the fabric.
Yeah. The clamping spoke holder, similar thing. You put that over that fabric, you're compressing that fabric.
Or
in here,
tearing.
we're assuming there's some kind of adhesive. You could start to damage that adhesive if you use that. So use their tool for that. Yeah, those were all some really interesting parts about building this wheel set.
Try different things. Again, it's what used to work in the past. With new equipment, new materials may not be working so good.
Yep. There's more turning. That's another note I had. There's just a lot more turns that you got to make on these spokes.
That makes sense with the fabric and the modulus. So steel does flex. You pull at a certain load, it's going to go a very small amount. That's the ratio of the stress and strain. Much different here. Okay, I think I have a rubber band. Whoa.
5 to 7 millimeters of stretch we're talking. So you got to take up that amount.
Turn. Makes sense.
Yeah, more turns. But yeah, overall, I was kind of impressed, and it was a lot of fun. So.
Geez, that's great.
Do you have any more questions about how this process went?
No, I think that's good. But I want to know, how does it ride? How does it feel? Notes of smoothness, notes of ivory. Or whatever you got.
Yeah, we'll find out. We're gonna build it up, we're gonna ride it around the factory, we're gonna ride it outside, and we're gonna ride it out at Sea Otter.
Tape it up, ride it up.
Yep.
Let's do it. Put any questions about those different paradigms in the comments. Have you built them? Have you ridden them?
What was your experience? Have you drilled out the hubs before? The normal standard J-bend hubs.
Yeah.
But on that note, we'll see you guys next time. Get out there, get your hands or your gloves dirty, and we'll see you next time.
Keep learning.